Well, hi, this is Bob again, and we're getting ready to take a look at the second part of Chapter 2, or the second session in Chapter 2. I broke this particular lesson into two parts because I thought it would work out better if we first establish how we did the histogram. In other words, this is what we've done so far. And we did the frequency polygon, and we did something called the ogive, which was based on cumulative frequency of the temperatures that we had for the highest temperatures in each of our 50 states. So it turns out we're going to do the exact same thing, 3 more graphs that are going to be just like the other ones, except we're going to call these relative frequency graphs. Now, when you read page 61, you'll see that they give us an example, like how we can compare the same subset of people, or the same subset of ages, or crimes, or sickness, civic participation, whatever, in different, for example, cities or different populations. And they use the example in the book of comparing the population of a city like Erie, Pennsylvania, which has got like 100,000 people. Let's say we wanted to compare the number of 50-year-old people in Erie, Pennsylvania versus the number of 50-year-old people in Philadelphia. And Erie has a population of 100,000, and Philadelphia has a population of 1.5 million. Well, what we could do was just divide each frequency by the population of the given city, and then multiply it times 100. Or, well, we don't have to multiply it times 100. If we leave it as a decimal, that's what we're going to use to do the graphs with. But you could multiply it times 100 and turn it into a percent. So if you've ever wondered, like when you read about crime statistics and you say, well, how can somebody compare the crime statistics in a city like New York City with a huge, millions population with a small town? They do it by taking the number of crimes of a particular type and dividing by the total population. And this is called relative frequency. So what I'm going to do, since the graphs are basically the same, I thought what I would do, and of course you'll be reading the little blurb there on 61, but what we're going to do is we're going to do example 2.7, and we're going to do a relative frequency histogram and a relative frequency polygon and a relative frequency ogive. And you're going to see that they're remarkably similar because they're based on the same ideas or procedure as what we did in the first part of this lesson. So what I'm going to do, since we should be really familiar with how those other graphs were derived, is I'm going to try to summarize so we can do the first two together, because there's really nothing new on these. And if you notice, I'm looking at example 2.7, and these are the 3 things we're going to do. We're going to construct a histogram, a frequency polygon, and an ogive using relative frequencies for the distributions of the miles that 20 randomly selected runners ran during a given week. So it's nice to know that it's very important for us to know that the number in this random selected group was 20. So what I'm going to do is I'm going to combine 2 graphs at once, and I perhaps could stop the recording to do this, but if you'll bear with me, or you probably have the option to fast forward a little bit, but I'm going to have the class boundaries. And again, this is an interesting skill, but we're still not in Chapter 3 where the main body of material starts, but these things are really helpful for us, and they sort of warm us up to what's coming. So what I'm going to do is since we're going to be doing the frequency polygon, we're going to be needing the midpoints of these classes. So I thought I would just save ourselves a little time and do the midpoints at the same time. It's just a very easy calculation. And then we'll have the frequencies. And then the last one, we're going to have relative frequencies. And we'll convert those as we go along. Okay, so, and again, you can follow along, or perhaps you've already fast-forwarded, but the first class was from 5.5 to 10.5 miles per week. I'll just go ahead and write these, and the next one would be like 10.5 to 15.5, then 15.5 to 20.5, you'll be doing the exact same thing on your homework problem like this. Okay. Now, remember how we found the midpoints. I'm going to do the midpoint for the first two, and then we'll go back to our trick. The first one would be 5.5 plus 10.5 divided by 2. And when we do that, we get 16 over 2, or 8. And I'll find the midpoint for one more. We'll take 10.5 and 15.5. I'm doing this second class here, adding them together and dividing by 2. And those add up to 26. Oops, lost something there. And 26 over 2 is 13. Okay, now we can easily see that the midpoints are going up by 5 each time. So I can just go ahead and put the rest of the midpoints in, and this will help us when we do our graph. Okay, so we're all done with the midpoints right now. We'll do the histogram first, the relative frequency histogram, then we'll come back and do the frequency polygon. Now, now we can go back to the chart at the bottom of page 61. There was one person, one runner, that did between 5.5 and 10.5 miles a week. Now, here's what we're going to do. We're going to change that one runner. We're going to go 1 divided by 20, which is 0.05. So instead of leaving that as 1, like we've done in the past to do the graph, let's say we wanted to compare this with 20 runners or another group of runners in a different city that maybe had a much larger population. Well, we couldn't compare the numbers necessarily, but we can compare the frequency, or basically the decimal or percents of the runners in the two groups. Now, what about the next one, the group class boundaries of 10.5 to 15.5? There were 2, and then 2 out of 20 would be like 1/10, which would be 0.10. You can see where these numbers are coming. If you look over on the top of the next page, you'll see where they got these relative frequencies here. And then in the next group, there were 3 runners. 3 out of 20 is 0.15. And then our next group, there were 5 runners. 5 out of 20. I can do this in my head, but 5 out of 20 is 1/4, or 0.25. By the way, the relative frequencies will add to 1, of course, and because what we've basically done is we're dividing by 20 each time, then we're adding up all the individual relative frequencies, and there will be 20 of them, and 20 over 20 is 1. Anyway, the next one is 4 out of 20. That's 1/5, or 0.20. And then we have 3 out of 20 and 2 out of 20 to finish off. Okay, and you notice that if we add all these relative frequencies up, they add up to 1.00 because we've accounted for each of the 20 frequencies in their individual classes. So now we're ready, with just a matter of a few steps, We have found the boundaries. We found the midpoints so we can graph our frequency polygon. We have the frequency in each class, and we're going to use that for both the relative frequency histogram and a relative frequency polygon. And we've got our values for relative frequencies to use for our graphs. And then all we have to do for the ogive is have what's called a cumulative relative frequency. And I'll walk through that after we do these two graphs here. So here's what I'm going to do. I'm going to grab a new page, and I'm over on, I can refer back to the values, but we've got all the values for us at the bottom or on page 62. Now, we'll start off by doing the histogram, and instead of frequency this time on the y-axis, we have relative frequency. And of course, on the x-axis, we have our miles. Now, notice that our highest relative frequency, you can just go right up to the top there, was 0.25. That was for the that was for the class boundaries of 20.5 to 25.5. So 0.25. This is for the bargram, by the way, or excuse me, our histogram. For miles, runner's miles. So the highest bar that we're going to have is 0.25, so I'll go up by 0.5 each time. And again, I'm doing this on a slippery screen, but you'll be doing it ideally on ruled paper or graph paper. So here'd be like 0.05, 0.10, 0.15, 0.20, and 0.25. Now, all we have to do now is draw the bars, and this will represent our cumulative frequency, our relative frequency histogram. So between 5.5 and 10.5, we only had 0.05. So what I'm using now is the very top. On top of 62, I'm using that chart with the relative frequencies there. And the first one for the class of 5.5 to 10.5 had a relative frequency of 0.05. So that would look very roughly like this. And then from 10, oops. Okay, that's a little better. Then from 10.5 to 15.5, the relative frequency was 0.10. Okay, and then the next one was 0.15. And then the next one was 0.25. That is not a very good looking graph, but again, we're just trying to get the idea of how to derive the graph. And then we go 0.20, and then we're at 0.15 and 0.10. Okay, well, if I took the time like the book did and shaded each one of these in, it might look a little better, but the idea being, or the idea of the lesson being, is what we're trying to get a hold of, is where are they getting these numbers and how are they plotting these graphs. So if it was shaded, it'll look a little better. It's not necessary to shade, but at least it looks better on my particular screen. Okay, so that takes care of the histogram, and I'm sure from their drawn histogram at the bottom of 62 that you can continue or see exactly the steps that we did and how they matched up with theirs. On the next page, I'm going to do the midpoints, and we'll make our frequency polygon. And this is shown and demonstrated up on the top of page 63. Okay, so for the frequency polygon, the exact same y-axis, it's going to be relative frequency, again. But on the x-axis, instead of the class boundaries, we're going to have our class midpoints. And we started off at, our first one was 8. And again, I'm on the top of page 62 in that first table there. Remember how we got our midpoints, and those are what we're going to graph now. So we have like 8, 13, 18, 23, 28, 33, 38, and 43. Well, we're going to need 43, but I'll hold off on that for a second. Remember, we're going to plot the relative frequencies first, and then we'll close it off by stretching above and below by 5. Okay, so again, 0.05, 0.10, 0.15, 0.20, 0.25. Okay, so our first midpoint matches up with the relative frequency of 0.05. And then our next one matched up with a relative frequency. I'm doing the class boundaries of 10.5 to 15.5, whose midpoint was 13, and that relative frequency was 0.10. Then our next class had a midpoint of 18, and that was 0.15. Then our next class had a midpoint of 23, and its relative frequency was 0.25. Okay, you can see they don't really go on. It looks like I'm plotting them all in the same line here, but you can see on page 63 that they don't quite all appear to fall on the same line. Anyway, our next one would be 0.20 at 33. And then we have 0.15 at, in the next class, 23 was 0.25, then 28, excuse me, 28 was actually 0.20, and then 33 is 0.15, and then the last one that we plotted for a midpoint was 0.10. Okay, and now remember, so we've got this so far, and I use that very roughly. Now we've got to find the zero axis, or the where x is equal to 0 on the x-axis there. And you may recall we just stretch out the next midpoint below the first value. In other words, it's 8. There's a difference of 5 here. So if we go to the left 5 units from 8, we're at 3. So this is closing off at 3 here. And if we go to the left 5 units from 38, it puts us at 43, and that's where we close off here. Okay, so hopefully from my presentation there of how we get the midpoints and use the relative frequency on the y-axis, we now understand how we got the frequency polygon. Now, there's one more of these to do, and this is going to be the ogive, or cumulative relative frequency. And I think what I'll do is I'll just derive a little bit of the graph and then refer you to it. If you look at the second table on page 62, this is how we got the cumulative relative frequency. Remember, this is just a running total, but instead of a running total of the individuals and their miles per week in each class, what we're now doing is adding up the individual relative frequencies as we go. And this would be step 2 here, where we add them up as we go along. So I'll do a little bit of that here just to kind of give us the idea. I don't think I need to do the whole thing. And then we'll draw the graph, and that'll be it for this lesson here. So, as I said, you have one of these problems here, and this will be helpful in deriving it. This will be our cumulative frequency. And then we have our cumulative relative frequency. Okay, so remember our classes. The first one was less than 0.5. Now, less than 5.5, of course, was 0. That is where we started out, okay? And so 0 divided by 20 is going to be 0, and so there wouldn't be anything in that particular, that's where our graph starts. So then less than 10.5, less than 15.5, less than 20.5, okay, so remember the next one we had a cumulative frequency of less than 10.5. If you look at the graph up above, actually what they're doing is they're going back to our original frequencies there, back on the bottom of page 61. There was no value below 5.5. Okay, so its cumulative frequency would be 0, and the cumulative relative frequency is 0, and that's just where we start. Now, between 5.5 up to or less than 10.5, there was one person, or one in that class, and so 1 divided by 20 is still 0.05. Just so you know, basically what I'm going to be doing is I'm going to be taking all the individual decimals for the relative frequencies on the top of page 62, and just make a running count of them. Now, if you recall, and there's 2 ways to find this out, you can go back to the bottom of 61 and see that there were between 10.5 and 15.5, there was a frequency of 2 runners in that class, but in terms of cumulative frequency, there were 3 runners that did less than 10.5. Okay, so that's where they come up with the 3 in the next class there, and 3 divided by 20 is 0.15. So remember, we're taking a cumulative total here. Okay, so then the next class, when we would find out between 15.5 and 20.5, there was a frequency of 3 runners, but that would be a total frequency of 6 represented in those first 3 class boundaries. So our running total would be 6, and 6 divided by 20 is the same as 3/10 or 0.30. Okay, so then, and remember these numbers, you can see them all. I'm trying to explain where they're getting the numbers in this particular column right here. Okay, then I'm just going to put the rest of them in there. The next one would be 11, and then the next one would be 15, 18, and then finally 20. Remember that our overall number of runners that we were following was 20. Okay, so 11, this would be to get the cumulative relative frequency for 11. It's 11 divided by 20, or 0.55. And then 15 out of 20, 3/4 or 0.75. 18 out of 20 would be 0.90. And of course, 20 divided by 20 would be 1.0, or 1.00. So what I've done is I've kept a running total of the frequency, that's cumulative frequency, and every time, with every entry of that cumulative frequency, I have divided that by 20 to get a cumulative relative frequency. I know it sounds really wordy, but that's what's happening, and the book gives us two nice tables for you to follow there. So now, finally, we can close off by drawing the ogive, or cumulative relative frequency. Now, this time we're going to have to go up to 1. I'm going to try to write decently here. And if you notice what the book did is they went up by 0.2 each time. So they got like 0.20, 0.40, 0.60, 0.80, and 1.00. Okay, and then we've got our class boundaries on the x-axis. This will be miles, by the way. So our first one was less than 5.5, 10.5, yeah, my previous computer had a much nicer and larger screen to deal with. Anyway, fortunately, this will be one of the last few things that we do involving graphs and so forth, and chapter 3 is pretty much all numerical. So let's go get we are now going to, on our y-axis is our cumulative relative frequency. There was no runner that did less than 5.5 miles, so we're going to start off at 0. And at 10.5, less than 10.5 was 0.05, which on my graph I can only estimate. If you use a taller y-axis, you can be more accurate in plotting your points there. And at less than 15.5 was 0.15. And less than 20.5 was 0.30. Oops, I'm a little high on that one. And less than 25.5 is 0.55. And less than 30.5 is 0.75. And then 0.90 at 35.5, that's smack in the middle there, and then 1.00 at 40.5. Okay, well, again, it doesn't look as nice as the books does, but we have explained how we got the values for the x and y axes, and we've covered how we have converted our cumulative frequencies into cumulative relative frequencies, and this would be the ogive for the runners. Runners, miles actually. Okay, well, I'd like you to read over the bottom of 63 there, where they introduce or discuss a little bit about distribution shapes. We'll refer to distribution shapes in Chapter 3, and I may elaborate a little bit more on those. But for right now, just reading it over and looking at the different distribution shapes, they're presented to us in the form of histograms. But as I've tried to show before, like if you notice that the first graph on the left on page 64, it says bell-shaped, and you may have recalled that I've tried to sketch that bell-shaped curve because that's the one that we're going to be carrying throughout the entire class, and we'll learn more and more about that after we get through with chapter 3. But anyway, read that over there, and I think I've only given you a couple of questions to in exercise 2.2 for you to draw. And I've asked you to draw the normal graphs for the histogram and the frequency polygon and the ogive, and then I've asked you to also draw their graphs in terms of relative frequency. Anyway, I will be back shortly with a very short lesson on stem and leaf plots, which will be helpful also, and then we'll move on to chapter 3. Thank you.